All right, guys, so we are on example 9. So how do we find the area for shapes that are more complicated? Break up the areas into shapes that we would recognize and add the area values together. All right, so we have this strange object. So we could cut this into sections. So for example, if we do this right here, if I could draw a straight line, that's a rectangle, right? And then if we draw a line right here, we have, that might be a rectangle or a square, I'm not sure yet. And then we have this triangle at the top. So since we cut this into 3 different shapes, we can figure out what the area of the whole thing is, right? All right, so if this section right here is 2 feet, then this section right here has to be 2 feet. All right, and then, oops, there we go. All right, so if this whole line right here is 6 feet, and this section is 4 feet, well, this whole line right here would also have to be 6 feet. So this does happen to be a square because this is also 2 feet long, this section right here, 2 feet long. If this is 2 feet long, so is this one. Okay, so this happens to be a square. We have a rectangle on the bottom, and of course our triangle's up here. So we're going to find the area of each of those 3 figures. So the rectangle, we want to multiply the base times the height. So we're going to multiply 6 times 2. So 6 feet times 2 feet is 12 feet squared. So that's the area of the big rectangle. And then we have a square right here, which the dimensions are 2 by 2. So 2 feet by 2 feet is 4 feet squared. And then our triangle also has a base of 2 and a height of 2. So remember, the area of a triangle is base times height divided by 2. So 2 times 2 is 4, and half of 4 is 2 feet squared. So our 3 areas that we're going to add together are 12 feet plus 4 feet plus 2 feet, and that's going to give us 18 feet squared. So anytime you have a crazy shape like this one, you want to divide it into recognizable shapes that you're familiar with, okay? All right, example 10 says find the area for each described situation. Create a drawing of the shape with the included information. Show all work. As in the examples, if units are included, then units should be present in your final result. Use 3.14 for pi and round answers to the tenths place as needed. So it says find the area of a rectangle whose length is 12.9 and height is 1/3 that amount. So 1/3 of 12.9. So the first thing I'm going to do is write 12 and 9/10. 12 and 9/10. Oh my goodness. 12 and 9/10. And we're going to turn this, so we want to find 1/3 of that amount. That means we're going to multiply by 1/3. So I'm going to turn this mixed number into a improper fraction. So 12 times 10 is 120. 120 plus 9 is 129/10. We want to know what 1/3 of it is. All right, so I'm going to see if 129 is divisible by 3, so I can make this smaller. So I'm going to add 9 plus 2 plus 1, which is 12. Since 12 is divisible by 3, that means this whole number is divisible by 3. So I'm going to divide 3 by 3 and get 1. And 129 divided by 3 is 43. So this is now 43. So I just simplify before I multiply in. So now I'm going to multiply straight across. 43 times 1 is 43. 10 times 1 is 10. So 10 will go into 40 4 times with 3 left over. So 4 and 3/10. 4 and 3/10, or in other words, 4.3 3/10 is written 0.3. So now we know that the height is 4.3. So we have a length of 12.9 meters, a height that's 1/3 of that, which is 4.3 meters. So now we're ready to find the area of this rectangle by multiplying 12.9 times 4.3. So 3 times 9 is 27, carry the 2. 6 plus 2 is 8, 3 times 1. 4 times 3 is 36. 4 times 2 is 8 plus 3, 8, 9, 10, 11, carry the 1. 4 times 1 is 4 plus 1 is 5. So we're gonna do 7, 14, 5, and 5 with 1, 2 digits behind the decimal. So it tells us to round to the nearest tenths. So the area of this rectangle is 55.5 meters squared. 55.5 meters squared. All right. All right, let me get rid of this. All right, part B, find the area of a triangle with base 24.5 inches and a height of 7 inches. So the base is 24.5, so I'm gonna write 24.5 because 1/2 is equal to 0.5, and 7 inches for a height. So we're gonna multiply area of a rectangle or triangle as 1/2 times the base times the height. So we're gonna go ahead and multiply 24.5 times 7, and then we're gonna half our answer. So 5 times 7 is 35, carry the 3. 7 times 4 is 28, 29, 30, 31, carry the 3, and then 14, 15, 16, 17. So 171.5, and then I'm going to half that. So 171.5 divided by 2. Bring that decimal straight up. All right, 2 will go into 17 8 times with 11 left over. 2 will go into 11 5 times. Bring the 5 down. 7 times 2 is 14 with 1 left over, and 2 will go into 10 5 times. So it's 85.75 inches squared. The directions say to round to the nearest tenths. So the area of this triangle is 85.8 inches squared. That is the area of that triangle. All right, let me get rid of this red ink. Letter C, find the area of a circle with a radius of 2 1/3 inches. Present answer in exact form and also computed or compute rounded form using 3.14 for pi. Present rounded form to the nearest tenth. I think it meant round, I don't know. Anyway, all right, so an area of a circle, area equals pi r squared. So we're going to square 2 1/3. So we're gonna, since 1/3 is a non-terminating decimal, you wanna try to keep it in fraction form. So the first thing I'm gonna do to square 2 1/3 is turn this into an improper fraction. So 2 times 3 is 6, plus 1 is 7. So my radius is 7/3, and I need to square 7/3, right? So 7/3 times 7/3 is 49/9. So 7 times 7 is 49, 3 times 3 is 9. So when it asks for the area in exact form, I could say the answer is 49/9 pi. Or I guess I could turn this into a mixed number. 9 will go into 49 5 times. And 5 times 9 is 45. So that means there would be 4 left over. So 5 4/9 pi would be an exact answer. But then if I wanted to round it, so anyway, this is an exact answer right here. And I should have written inches squared to be more precise. 5 4/9 pi inches squared. Or now it wants a rounded answer. So I'm going to go back to my improper fraction. I'm going to multiply 49/9 times 3.14. I can put those both over, or that one over 1. I can multiply straight across. So I get 49 times 3.14, which is 153.86 over 9. And then 153.86 divided by 9 is, I'm running out of room, 17. My calculator says 17.09. So I would write 17.1 inches squared. Okay, so this is the exact answer. This is my rounded answer right here. All right. All right, now you guys try. I think I have quite a few for you to try. Here's D. Let's see, go do A through D on this page, and then come back and check your answers with me. Okay, so go ahead and pause the video, try these on your own, and then come back and check your answers. All right, number 11, find the area given each described situation. Include a drawing of the shape with the included information. Show all work. As in the examples, if units are included, then units should be present in your final answers. Round answers to tenths unless otherwise indicated. Find the area of a square with side length 4.2 feet. So we're just simply going to multiply 4.2 by itself, or in other words, we are squaring 4.2. So 4.2 squared is 17.64, so 6 feet squared. That's the area of a square with a side length of 4.2. All right, then if we have a rectangle, that's 4.2 times 3.8. 4.2 times 3.8 is 15.96. So if I'm rounding to the nearest tenths, that 6 will turn that 9 into a 10. And the 10, I would carry the 1, so it would be about 16 units squared. About 16 units squared, that's a 9. And it tells me to round to the tenths place. Okay. And then finally, letter C, or not finally, because we have a letter D also. So if I have a triangle with a height of 7 and a base of 12, so we're going to multiply 12 times 7, and we get 84, and then we have to half 84, and I get 42 inches squared. All right, and then letter D, it says find the area of a circle with a radius of 6 inches. So here's my circle, radius 6 inches. Present answer in exact form. All right, so the exact form, so this is for area. So area equals pi r squared. So my radius is 6, so I'm going to square 6, and I get 36. So 6 squared, that means 6 times 6 is 36. So my exact answer would be 36 pi inches squared. But then my rounded answer, I'm going to multiply 36 times 3.14. 36 times 3.14 is 113.04 inches squared. So that is my exact answer, and this is my rounded answer. Okay, it's in a quick text, sorry about that. All right, we're going to go on to the next session. Next page. It says the basic formulas for area will help us find the area of more complicated figures such, oh, it's got to show us an ice cream cone again, doesn't it? As seen below, this is the same problem we found the perimeter for earlier. Find the area for the given shape, compute using 3.14 for pi, and round to the nearest tenths. All right, so the figure on the bottom, is a triangle. And the figure on the top is half a circle. So we're going to find the area of half a circle. We're going to find the area of a triangle. And the last thing we do is add those two areas together. All right, so the triangle, remember you have to have a 90-degree angle. So let me write, if I was, where did my pen go? Oh, trying to write on the wrong thing. All right, so basically our triangle, if you think of it kind of as upside down, our 90-degree angle is the side that's 3 inches long, and the height is 14.92. So that's the two heights, or the two lengths that we have to use for the base and the height of our triangle. All right, so area of a triangle is half the base times the height. So our base is 3, so we're going to multiply 14.92, that's our height. We're going to multiply it by 3, and then we're going to half it. All right, so we're going to do 14.92 times 3 divided by 2. So the area of the triangle on the bottom is 22.38 inches squared. So that's the area of the triangle. And then let's pretend for a second we have a whole circle with a diameter of 3, right? And so now we need to know the area of a triangle, or excuse me, area of a circle is pi r squared. Well, if the diameter is 3, we need to know half that number to figure out what the radius is. So the radius is 1.5. So the first thing we're going to do is square the radius. We're going to square 1.5, which is not 3. We're not doubling it, we're squaring it, right? And then we're going to multiply that by 3.14. Okay, so I'm going to do 1.5 times 1.5, which is 2.25, and 2.25 times 3.14 is 7.065 inches squared. Now I know it says to round to the nearest tenth, but that's when we get our final answer. So try not to round until you get your final answer. So now the area, oh, excuse me, that is the area of a whole circle, right? This would be, if we had a whole circle, that would be the area. So since this is half a circle, we still have to divide that number by 2. So now I have the area of half a circle is 3.5325 inches squared, because it's half a circle. So now we're going to add our 2 areas. Make sure when you're adding with decimals, you line up those decimals on top of each other. So 5, bring down the 5, bring down the 2, 11, 9. I'll bring the decimal straight down, 5 and 2. And then finally, it tells me to round to the nearest tenths. Well, the 1 keeps the 9 a 9. So the area of the whole figure is 25.9 inches squared. That's the area of the whole ice cream cone. All right. Let's see what this says. We can combine our knowledge of area perimeter to solve problems such as this one. Wally is still fixing up his house and has a flooring project to complete. He wants to buy enough bamboo flooring to cover the floor space in rooms A, C, and the hallway, B, and enough bamboo edging for baseboards in all the spaces as well. How many square feet of flooring and how many feet of baseboards should he buy? All right, so if we're laying down any kind of flooring, whether it be carpet or hardwood floors or whatever, basically we want to know what is the area. So we want the combined area of both rooms in the hallway. But then the baseboard, as you guys know, baseboards go around rooms and hallways. So are we putting the baseboards? Yes, the baseboards in the hallway also. So the distance around is the perimeter. Okay, so we want to know what is the combined area of the whole figure and what is the combined perimeter of the whole figure. Now, the only tricky part I see is that we have doorways. So the doorways would not affect the area because you still have to put carpet in doorways, but it would affect the perimeter because you do not put baseboards on doorways, right? You would leave those open, obviously, or it would be a tripping hazard. All right, so the first thing we're going to do is find the area of each specific room and hallway, and then we're going to add all of those together. So this rectangle has dimensions of 15 feet by 10 feet. So 15 feet times 10 feet would be 150 feet squared. And then this other room over here is a square room. So each side is 8 feet. So the area is 64 feet squared. And then our long hallway, let's see, this section is 4 feet long. And this whole section, let's say from here, let's see. So if this is 8 feet, then this combined has to be 8 feet. This combined section has to be 8 feet. So if this is 4 feet long, this has to be 4 feet long, right? Oh. This section of the wall is 4 feet long, okay? So if this wall right here is 10 feet long, this whole section would have to be 10 feet long, right? So that means that this section just from here to here, if this is 4, this has to be 6. So these two sides are 6 feet long, right? So the dimensions of this long rectangle are going to be 3 feet by 14 feet because we have 6 plus 8. So 3 feet by 14, 3 feet by 14. So 14 times 3 is 42. So this section is 42 feet squared. So we're going to add up our area. So our big room is 150 feet squared. Our small room is 64 feet squared. And then our hallway is 42 feet squared. 6, 15, 256 feet squared for the whole space. All right, hopefully you guys agree with me. I hope I did that right. All right, so now we're going to talk about perimeter. So we want baseboards around all the walls, right? So let me get rid of some of this stuff. Okay. So we want to put baseboards around this whole room right here. So if this wall is 10, this room wall is 10, right? So 10 plus 10 is 20. 15 plus 15 is 30. So we have 30 plus 20, which is 50. All right, we're going to take the doorways off. The very last thing we do is going to take the doorways off, okay? All right, so then we have this perimeter. So let's not count this doorway for the inside hallway, all right? So that means that we're going to count 4 and 6. So that's a 10-foot wall. A 10-foot wall. So we have 10 feet for this wall. And then we have 3 feet. And then from here, from 6 all the way to this section, this is an 8-foot wide section. All right, so 6 plus, it would be 8, but we're subtracting away this door frame. So it's going to be 6 plus 6. So 6 plus 6 is 12. Oh my word. What is wrong with this? Sorry. All right, so 6 plus 6 is 12. And then finally, we have to put baseboards on this 3-foot wall as well. So basically we got this 10-foot wall, not including the door frame, 3-foot wall. This 6 plus 8 minus 2 is 12, because we don't want to put baseboards on the door frame, plus the 3-foot wall. So that's 10. So anyway, 15, 16, 17, 18. So 38 feet. All right, I'm going to go back up to this room and go ahead and subtract from, we added the perimeter of this whole room, but we have to take away the 4 feet, or excuse me, the 2-foot door. So we need to take away the 2-foot door. So that's 48 feet for our big room, okay? So the perimeter of this room minus the door is 48. The perimeter of the hallway minus the doorway is 38 feet. And now we're gonna do the same to this one. So each side, each wall of this room is 8 feet by 8 feet. So we're gonna multiply 8 times 4. So it's 32 feet, but then once again, we have to take away this 2-foot door. So the perimeter that needs baseboards in room C is 30. All right, so now the last thing we do is we add 48 plus 38 plus 30. And the perimeter of the whole room, 38 plus 30, is 116 feet. We need 116 feet of baseboards. A lot of work. Hopefully I did not confuse you guys. I kind of confused myself. All right, but y'all check me, make sure I'm right. All right, now these are good type of questions to be able to do. I know you have a couple of these on, I think I saw it on your homework or quizzes or both, I'm not sure. But you will have to be able to figure out how to find the area of just the shaded part. So first of all, let's look at the top figure. The top figure, we're going to assume that this is a square, right? So the outside of this figure is a square. So we have to find the area of the square, but then basically what we're going to do is subtract from that the area of the circle. All right, so how do we figure out the length of our square? What's the whole length of this right here? Well, it seems that if I could draw a straight line, oh my word, I'm so bad at this. It seems that this is half of our length, right? So if half of our length is 4, that means each side of our square has to be 8 inches. So what's the area of a square that has each side 8 inches? Well, 8 inches times 8 inches is 64 inches squared. So the whole square is 64 inches squared. However, they took out the center of the square that looks like a circle. So we're going to find the area of the circle, pi r squared. Now I'm assuming that we're going to use 3.14 for pi. The directions aren't here, so I'm assuming that's what it's going to tell us to do. So the first thing we're going to do is square the radius. So the radius is 4, so we're going to square it. So 16 is 4 squared, 4 times 4. And now we're going to multiply 16 times 3.14. And we get 16 times 3.14 is 50.24 inches squared. And so since we started with a circle that was 64 and we're subtracting from it 50.24, line up those decimals. We're going to make this a 10, a 9, and a 3. So 10 minus 4 is 6. 9 minus 2 is 7. Bring down our decimal. 3, 1. So the area of just the shaded part is 13.71 inches squared. The shaded part is 13.71, or 76, excuse me. 13.76 inches squared. All right, so let's go to the bottom of our screen here. So we want to find the area of the shaded region only. So we're going to find the area of the whole rectangle, and then we're going to take out that triangle that's in the middle, okay? So what are the dimensions of our whole rectangle? So the whole rectangle is a 12 by 5. So 12 times 5 is 60. So the area of the rectangle is 60 inches squared. And now we need to know the area of our triangle. So base times height divided by 2. So our base, so here's our right angle, right? Here's our right angle. And so the two sides that create a right angle are 7 by the height of this triangle is actually the height of the rectangle, which is 5. So 7 times 5 is 35. And half of 35 would be 17.5. So 17.5 inches squared. So we started out with a whole rectangle. We're subtracting out that triangle. So we would have to add a 0 right here so we could borrow, make it a 10, and then make that a 9. So 10 minus 5 is 5, 9 minus 7 is 2, and 6 minus 1 is 5. So after taking out the triangle in the middle, our area for the shaded section only is 52.5 inches squared. Okay. All right, what else we got? All right. Hold on one second. Let's see. Let me get rid of this. All right. So here we have a circle, a big circle. And basically, if you imagine the middle part is a white circle, right? So we have a big red circle and they took out the section that looks like a white circle, okay? So basically that's what we're gonna do. We're gonna find the area of the biggest circle and then we're gonna subtract out the area of the white circle. So that's what we're gonna do. So the big circle has a radius that is 8. So from here all the way to the edge, that's 8. My reds are the exact same color. From here to here, that is 8 centimeters, right? So we want to know what is the area, pi r squared, of the great big full circle, the red one, as if it were a complete circle. So we're going to square our radius of 8. So we're going to square 8 and then multiply 8 times 3.14. Whoops, that does not need to be equal. So 8 squared is 64. So 64 times 3.14. 64 times 3.14 is 200.96 inches squared. I guess it's inches. And then if we look at our white circle, it has a radius of 7. So from here to here is 7. So then our second circle, our radius is 7. So we're going to square 7. And then we're going to multiply that by 3.14. So 7 squared is 49, and 49 times 3.14 is 153. Oh, I should have written that smaller. Let me move this over. All right, so if I multiply by 3.14, that equals 153.86. So we're subtracting out the white circle. So 6 minus 6 is 0, 9 minus 8 is 1, 10 minus 3 is 7, 9 minus 5 is 4, and then that became a 1. All right, so basically the area of just the red section now is 47.1 or 47.10 inches squared. All right. So now the bottom question, or the 4 questions at the bottom, says, first of all, what is the area of this given rectangle? So the area of this given rectangle is 6 feet times 4 feet, which is 24 inches squared. Or not inches, feet. 24 feet squared. And then the question says, if each side was doubled, what would be the dimensions? So we had 6 feet. If we doubled that, it would be 12 feet. By 4 doubled is 8. All right, so now the question is, what would be the new area of the doubled rectangle? So now if we multiply 12 times 8, we would have 96 feet squared. So the question for 4 is, how many times bigger is the area from question 3 than question 1? So even though we doubled the size, did the area double? No, because if it doubled, the new area would be 48, but it didn't double. It more than doubled, right? So how many times bigger is 96 than 24? Well, 96 divided by 24 is 4. So it didn't get 4, or it didn't double, it quadrupled. It's 4 times bigger. Now the perimeter would just double, because if we doubled it and we added up the sides, if you're doubling two numbers and you're adding, then the difference of the two numbers would be double, right? However, we didn't just double 6, we doubled 4, and then we multiplied those two numbers doubled together. That's why it's not twice as big, it's 4 times bigger. Okay, so you will see that question in your homework and on your quiz and probably on your test. How, if you double the dimensions and then you find the area, how much bigger would the area be? The answer is 4 times bigger. So just keep that in mind. All right, excuse me. And then I was going through your quiz, and they were all, you know, lining up beautifully with your homework problems and these type of example problems. And then I saw this weird question on 17, just out of the blue. It didn't have anything to do with any of these other things. Is basically, it says, if find the complement of an angle that has 8 degrees, that's 8 degrees wide. And so I was like, we haven't talked about complementary angles. But basically, one of the questions is going to have you recognize, first of all, classify a type of angle. So do you remember your angles? So you have a right angle, which is 90 degrees, correct? And then you have two different types of angles. You have either acute angles or obtuse. So you could say acute little angle, which means it's less than 90 degrees. Acute angles are less than 90 degrees, and obtuse is greater than 90 degrees. So you have a right angle, an acute angle, and an obtuse angle. Or of course we have a straight angle that equals 180 degrees. A straight angle. So one of your questions asks you to classify an angle, either an obtuse angle or an acute angle. And then, like I said, this is quiz number 17. I don't know if we have the same questions in the same order, but basically it wants to know the complement of an angle that's only 8 tiny degrees. That would be a tiny, tiny angle. Well, just a little vocabulary. Complementary angles are two angles that add up to, I even put that wrong. Complementary angles add up to be 90 degrees. This is not right. My PowerPoint's wrong. Complementary angles add up to be 90 degrees. This is, gosh. So basically you would subtract 8 from 90 and the complementary angle would have to be 72 degrees. Supplementary angles add up, supplementary, oh my goodness, supplementary angles add up to be 180. Complementary angles add up to be 90. So for this particular question, the complement of an 8-degree angle would be a 72-degree angle. A 72 plus 8 equals 90. So that's the answer. If you get a question about supplementary angles, the two angles would add up to be 180 degrees. So like I said, I only saw that once. It was very random, just kind of thrown in there. We haven't talked about these type of angles. But anyway, on your quiz, you'll have to know that two complementary angles add up to be 8 degrees. Or, I'm such a dork. complementary angles add up to be 90 degrees, okay? All right, so that's all I had for this section. So hopefully you found that not too difficult. So I will schedule a meeting for tonight at 7:45 just to see if you have any questions. So hopefully you'll have a chance to look at your homework problems and your quiz problems and go through my examples with me. And so if you have any problems or any comments or anything you need to have clarified, please join me tonight at 7:45 on our Collaborate meeting. All right. Thank you guys. See you later.